in question C, we're again dealing with a quadratic equation. We have an x squared, an x, and a constant term. We should be able to use a quadratic formula. The difference is we're just dealing with more variables now. We just have to keep track of those variables algebraically. So before I can apply the quadratic formula, I should make it equal to 0. Okay, so that's going to be equal to 0. And then I just need to identify my a, the coefficient in front of the x squared. That's going to be n squared. My b, it's going to be all of that in front of the x. And then my c, which is going to be m squared. So I've got a quadratic. I can use quadratic formula. I've identified my a, b, and c terms, so I just plug it in. So negative b is going to be negative 2mn plus minus. The square root part is going to be something called, we're going to end up calling the discriminant. It's going to be b squared. So 2mn squared is going to give me 4m squared n squared. So just be careful of the algebra, keeping track of all those terms. Minus 4 times a n squared times c, which is m squared. Okay, just gonna color code this all. So there's my a, there's my b squared and b, and my c ends up here. Now I want you to notice that we're going to end up with 0 inside the square root. Okay, and that's going to tell us something about what kind of solution we have. So I'm just going to fill the rest of this out. 2 times a, which is our n squared again. So this is our quadratic formula. So this is a solution. But this solution is interesting. It's a little bit different because that square root part ends up being equal to 0. So when I simplify this, I end up with x squared is equal to negative 2mn plus minus square root of 0. That 0 inside the square root, that inside the square root part is called the discriminant. The discriminant equaling 0 means that when I find my solution here, I'm going to go from the middle, which is 2mn over n squared, and I'm going to add 0, and I'm going to subtract 0 to give me my two solutions. Well, if I add 0 and subtract 0, really I'm in the same place, so I only have one answer here. So this actually gives me a unique solution, or just one solution. So when I simplify this, I end up with the 2's cancel out, so I end up with negative. The m cancels out, so I end up with negative m on top. N and n squared simplified to just n. So my solution is just one solution at negative mn. So what does that mean? If I were to think of what this graph looks like, it must be a parabola that just touches the x-axis. There's only one solution. That means then if I start at my middle, I'm going to add 0, subtract 0. Well, that means that both solutions are going to end up in the exact same spot. That's going to be at wherever negative mn is. Not only that, because that 0 is a perfect square, this also means that this was actually factorable. Okay, so this is actually a factorable quadratic. So if I go back to my quadratics here, okay, so if I want to factor this, I can write this as a factored quadratic. So starting with n squared, x squared, plus 2mnx plus m squared equals 0. Well, this actually follows the quadratic pattern for all the variables. There's an nx all squared, there's an m all squared, and then there's an mnx in the middle term. So if I were to factor this, to get n squared x squared, I need n times x To get the m squared down here, I need a plus m, and this term is nxm, or I'll write a little bit better, is m nx, m nx. There's my two m and x's. This really is a perfect square of nx plus m squared equals 0. I can solve this by square rooting. I get nx plus m equals 0. Solving for x, I'm going to end up with negative m divided by n, and there's my solution algebraically by factoring. Okay, and I get the exact same solution as if I use the quadratic formula.